Welcome to all. This is Purnachandra Rao from EEE Department, SESI Institute of Technology, Thadepalli. Today I am going to discuss about the fundamentals of digital circuits in logic gates. What are the logic gates? In the binary lesson, we are discussing switches into the inside of the computer. Okay, logic gates are the switches that's turn on, turn off of the depending upon the user is doing. There are building of the blocks how to computer works. These are the switch. Definition of the logic circuits: a collection of the individual logic gates connected with each other and produce the logic design known as the logic circuit. These are the following logic circuits. First one is the decision making. Second one is the memory. A gate has two or binary inputs and a single output. In the have the consider as the one gate have the two inputs. These are the binary two inputs and output is only one output. In the case of gate have the two or more inputs and output is only one put. These are nothing but a gate. Okay, let's then go to these are the basic logic gates. These are the following are the three basic gates. First one is the NOT gate, second one is the AND gate, third one is the OR gate. Each gate performs the different logic function. You can derive the logical function and Boolean or logical expression by combining of these three gates. These are the very important gates. First one is the NOT gate, another one is the AND gate, and third one is the OR gate. These are the by using of derivation of the Boolean logic expressions. First I am going to the NOT gate. It is the simplest form of a digital logic circuit is the inverter or the NOT gate. It consists of one input and one output, and then input can only binary numbers, namely zeros and ones. Only it can use in inputs as zeros or 1. Suppose if you have the input is 0, the output is 1. If you have the input is 1, output is 0. This is the NOT gate. NOT gate is the most simple logic gates. All it does takes the input that either on or off. Suppose if you have the 0 is given, this is the off, 1 is given is the on, and this splits off the output of the opposite. Suppose if 1 is will given to the input and output is 0. 0 is the given the input and output is 1. Another name of the NOT gate is the very important is the inverter, because the inverter takes the opposite input. This is the NOT gate symbol. This is the NOT gate is the triangular base. Is the have consider as the bubble. Have the only one input, one output. Suppose in the case of input is 1 is given, output is 0. In the case of input is 0 is given, output is 1. These are the inverter. Suppose you have the input is 1, getting the output is 0. If you have the given the input is 0, output is 1. These are the NOT gate. This is the suppose you have the input. Suppose if you have the given the A is the input, the NOT gate is applied. This is the A bar. This is the inverter gate. Okay, NOT gate. This is also called as the inverter. Suppose A is the input. Suppose you have the bubble in after the triangle or before that the triangle. These are the same principle. This is the suppose if you have the input is A, output is A bar. This is the inverter. Input is A, after the output is A bar. This is the bubble is after that triangular or before the triangle. So both are same. Suppose this is the truth table. Input is A, output A bar. This is the suppose input is 0, getting the output is 1. Input is 1, getting the output is 0. This is the NOT gate. Next, second gate is the AND gate. Unlike NOT gate, AND gate have the two inputs. Okay, suppose if only turn on the both inputs is on, if only one input is on, split the out of off. Suppose if both inputs are off, split off the out of. Suppose you have the consider as the AND gate. Suppose you have the input is two inputs, output is one outputs. Suppose in the gate of suppose both inputs are ones, you getting the output is 1. Both inputs are, suppose input 1 and input 2 is both are 1s, output is 1. If any one 0 or both are 0, you getting the output is 0. Suppose in second AND gate, if input is 1, output is 0, getting the output is 0. Suppose if both are inputs are 0s, getting the output is 0. Okay, these are nothing. AND gate. Next, AND gate have the logic circuit have two or more inputs of single output. The operation of the gates output of the binary if only all inputs are binary 1. Similarly, one or more inputs are binary 0, output will be binary 0. These are the diagram. Suppose both are AND gates, A and B is the inputs, output is Y equal to A into B. This is the truth table. Suppose input A and B, output is Y equal to A and A into B. Suppose A is 0, B is 0, output is 0. Because of in the case of AND gate, both inputs are 1, the output is 1. This is the high. Suppose A is 0, B is 1, output is 0. A is 1, B is 0, output is 0. Both inputs are high. 1, A is 1, and also B is 1, output is 1. This is the AND gate. AND gate truth table. Another way of the truth table, suppose you have the diagram, truth table have the diagram. Suppose you consider as the 0, 0, output is 0, 0, 1, 0, 1, 1, 1. These are the another way of the truth table. This is nothing but a, and suppose input is 1, input is 2. Suppose 0, 0, the output is, suppose both inputs are zeros, 0. Suppose any one output of the 1, 0. Both inputs are 1, the output is 1. These are the another way of the truth table of the AND gate. Next, then go to OR gate. OR gate is also known as the, suppose you have the two inputs. If any input is 1, output is 1. If any input is 1, output is 0. Both inputs are 0, output is 0. Suppose in the case of OR also needs the two inputs. OR needs the one input to the ON, split out the ON. It is off, both inputs off, all are off. Suppose consider as the OR gate. This is the symbol of the OR gate. So we have the two inputs. Okay, these are the two inputs. Output is only one output. This is the OR gate. Suppose if you consider as the input, suppose consider as one input is 1, one input is 0, output is 1. Suppose both inputs are zeros, 0, 0, getting the output is 0. Both inputs are 1, getting the 1. This is nothing but a OR gate diagram. This is the OR gate as the another basic logic gates. Like AND gate have the two or more inputs and a single output. The operation of the OR gate such as the output is the binary 1. If all inputs are binary 1 and output is binary 0, when all the inputs are is binary 0. Okay, these are the diagram. A and B is the inputs, output is Y equal to A plus B. These are the AND gates. Input, consider as the truth table. Input is A and B. A is 0, B is 0. Getting the output Y equal to A plus B is the 0. Okay, another one is the A is 0, B is 1. Output is 1. If any input is 1, output is 1. Both our inputs is 1, also getting the output is 1. Okay, another is the A is 1, B is 0, getting the output is 1. Both inputs are 1, A also 1, B also 1, getting the output is 1. These are the AND gate diagram. This is the NAND gate. Suppose AND gate is nothing but both inputs are is 1, both inputs are 1, you getting the output is 1. Adding of the NOT gate of the AND gate, this is also called as the NAND gate. The NAND gate construction of the expression of NOT and AND gate, and NAND gate is the AND gate followed by the inverter. The algebraic expression NAND gate is Y equal to A into B. Okay, these are nothing but, suppose AND gate inputs is A and B, A and B. Adding of the NOT gate, consider as the NOT gate Y equal to A dot B, A into B bar. This is also called as the NAND gate. Okay, suppose simply derive the diagram. These are nothing but NAND gate simple. You consider that the AND gate have the consider as the bubble A and B, this is Y equal to A dot B bar. Okay, suppose you consider as the truth table. Input A and B, output A into B. This is not considered as the AND gate. Suppose in the case of AND gate, both inputs are 1, they consider as the 1. Okay, if any input is 0, the output is 0. Suppose you consider as the A, B, both are zeros, AND gate 0. 0, 1 also 0, 1, 0 also 0, 1, 1, 1. These are nothing but consider as the AND gate. Then go to this AND gate is applied to the output is applied to the NOT gate. This is also called Y is the Y bar. Okay, suppose these are the simply invert. Suppose if you have the in the case of AND gate output is 0 converted into NOT gate is nothing but 0 is converted into 1. 1 is converted into 0. Suppose in the case of both three outputs are zeros. 0 is converted into 1, 0 is converted into 1, 0 is converted into 1, 1 is converted into 0 because of the inversion of the output. This is nothing but a NAND gate. Simply this is nothing but a input is the A 0 0, both inputs are A and B are both inputs are 0, you getting the NAND gate output is 1. Simply reverse. Okay, because of one input is 0. Okay, now so one input is 0, output is 1. One input is 1, another output is 0, getting the 1. Both inputs are 0 once, getting the output is 0. This is nothing but a NAND gate. NOR gate. NOR gate is nothing but a, suppose you consider as the OR gate. In the case of OR gate, have the any input is 1, getting the output is 1. Any input is 1, getting the output is 1. Or two inputs are 1, getting the output is 1. This is the addition of the NOT gate is connected to the OR gate. This is also called as the NOR gate. The term of the continuation of the expression NOT OR gate. The NOR gate of the OR gate followed by the inverter. The algebraic sum of the output of the expression NOR gate is nothing but a y equal to a plus b bar. These are the symbols. Okay, suppose you consider as the OR gate. OR gate, the symbol is both inputs are A and B is the inputs, output not OR gate output is A plus B. Okay, he connected the NOT symbol, this is the bubble symbol is connected y equal to A plus B bar. Okay, total simply this directly is simplified by the both inputs are A and B is connected to the NOR gate. This is nothing but y equal to A plus B bar. Suppose you consider the truth table, input is both inputs A and B have the inputs. Suppose A is 0, B is 0. You getting the OR gate 0. Okay, we getting the. Suppose if any input is 1, output is 1. This is nothing but OR gate output. Y equal to A plus B. Suppose A is 0, B is 1. You getting the output is 1. Suppose A is 1, B is 0. You getting the output is 1. Both inputs are ones. A and B also ones. You getting the output is 1. Okay, these are the simply inverter of these outputs. OR gate output, because of the OR gate is connected to the NOT gate. This is the y equal to A plus B bar. This is the y equal to y bar. This is the nothing, simply inversion. Suppose the OR gate output is 0. He converted NOT gate is the 0 is converted into 1. 1 is converted into 0. 1 is converted into 0. And also 1 is converted into 0. These are the total outputs. Suppose in the case of total logic diagram, total truth table, suppose inputs A and B, both inputs are 0. You getting the NOR gate is the 1. Any input is 1. Suppose A is 0, B is 0, you getting the output is 1. A is 0, B is 1, you getting the output is 0. Okay, A is 1, B is 0, you getting the output is 0. Both inputs are 1s. You getting the output is 0. This is the NOR gate. XOR gate. XOR gate is the short way of the exclusive OR. Suppose OR and XOR needs to input to the OR for input the split out of the on. Unlike OR, both inputs is on, XOR split the off. Suppose have this is nothing but a exclusive OR symbol. This is have the two inputs, one output. You getting the one output. Suppose in the case of exclusive OR, XOR is nothing but a exclusive OR. Suppose one input is 1. Another input is 0. You getting the output is 1. Okay, now next then go to both inputs are 0. In the case of exclusive OR, both inputs are zeros. You getting the output is 0. Okay, in the case of both are ones, inputs both are ones. You getting the output is 0. Okay, now simply revise. One input is 1. Remaining input is 0. You getting the output is high. You getting the output is high. Both are 0 or both are 1s. You getting the output is 0. 0 is nothing but low. Okay, then go to diagram. Okay, this is nothing but exclusive OR. A and B is the inputs. This is the symbol of the exclusive OR. This is the A exclusive OR B. This is nothing but a exclusive OR B. These are nothing but derive the A bar plus B. A bar into B plus A into B bar. This is a simplified expression. A exclusive OR is nothing but a bar B plus A into B bar. Suppose you have the input, A is the input. Okay, A bar is nothing but suppose A input is 0, A bar is the 1. Okay, A equal to 0, A bar is the 1. Okay, then go to A is the 1, A bar is the 0. A is the 1, B bar is 0. Consider as the A and B. Because of the A exclusive OR is nothing but A bar B plus A into B bar. Next then consider as the B's. B input, B is 0, okay, B bar is nothing but 1, B is 1, B bar is nothing but 0, B is 0, B bar is nothing but 1, B is 1, B bar is nothing but a 0. You can consider as the output is Y equal to A bar B, same, A bar B plus AB bar, nothing but, suppose A bar, Y 0, this is the A bar B is nothing but, both are with the nothing but a, and again A bar B, this is nothing but a 0, okay, plus this is consideration of A bar B, this is nothing but a 1, this is A bar B consideration 0, this is the same as 0, consider as plus A bar B, A B bar 0, A B bar 0, A B bar 1, 1. Total output is Y equal to A bar B plus A B bar. This is also called the Y output is Y. This is the output 0, 0. This is the between the A bar B plus A B bar in the between the OR gate. This is nothing but 0. Okay, getting the next one is the OR gate is applied, you getting the output is 1, 0, 1, OR gate is applied, you getting the output is 1, 0, 0, you getting the output is 0. Okay, then exclusive OR and exclusive NOR gates. Exclusive and exclusive NOR digital logic circuits that can use the 2 or more inputs. XNOR gate returns the output opposite to the XOR gate. XOR gate, XOR NOR gate is also denoted by the XOR and XNOR respectively. These are nothing but exclusive OR NOT gate, XNOR gate. Okay, in the case of exclusive NOR gate, how the exclusive OR getting the NOT gate is applied, this is nothing but exclusive OR. Suppose you have the inputs A and B, you can exclusive OR is connected to the bubble, this is nothing but a exclusive OR B bar. Okay, A exclusive OR B bar. Suppose this is the inputs A, B. Okay, A, B. Suppose inputs both are zeros, A 0, B 0. Okay, now this is the exclusive OR B is nothing but a 0. Okay, now suppose in the case of A and B, A is 0, B is 1, exclusive OR is nothing but a 1. Okay, next then go to A and B, both A1, B 0. Okay, exclusive OR is nothing but a 1. Then go, both are 1s, A and B are 1s, exclusive OR nothing but a B. Is converted into NOT gate, is applied to the NOT gate. This is the 0 is converted into 1, 1 is converted into 0, 1 is converted into 0, 0 is converted into 1. This is nothing but a exclusive OR. These are the main application of the logic gates. Building of the complex system that can be used as the different fields, such as first one is the genetic engineering, second one is the nanotechnology, in the case of third one is the industrial fermentation, fourth one is the metabolic engineering and medicine. These are the mainly used in logic gates. Another one is it can be used as the multiplexers, adders and multipliers. It performs the several parallel logical operations. It used the simple house alarms or fire alarms in the circuit, the automatic machine of the manufacturing of the industry.